In this question, we're told that there are two different ways to get to the same product, the product 336. You can take the estimated time multiplied by the regular hourly rate, that should give you 336, and you can subtract $2 from the regular hourly rate and add 4 hours to the estimated time, and that product will also be 336. Now, it's very, very likely that the factors are all integers, both because this is the GMAT and because all the answer choices are integers and because the product 336 is an integer and because the differences of estimated time and actual time and regular hourly wage and actual hourly wage are all integers. So I would say that it's fairly safe to go ahead and assume that we are dealing with a divisibility question where all the numbers are positive integers.
So if we look at the answer choices here, what do they represent? Each answer choice is supposed to be the estimated time. And if I add 4 to each of them, that would give the actual time. So if we're in agreement that this is a divisibility question, now would be the time to factor down the number 336. One good way to do that is to identify that 336, each of those is a multiple of 6, so we can pull 6 out as a factor, and we're left with 56. Right? It's 336 is 6 times 56. Now 6, of course, is 2 times 3, so I'll circle those because they're prime. And 56 is 7 times 8. 7 is a prime, so I'll circle that one. And 8, that's 2 cubed. Now I can circle that. And I have my prime box. 336 is made up of 2 to the power of 4, 3 to the power of 1, 7 to the power of 1.
Now in the GMAT, when you have a product that can be arrived at in two different ways, like in this case the number 336, it's almost guaranteed that that number will be some kind of difference of two squares. And so if you can look at 336 and identify how you could possibly get that number by subtracting a perfect square from a bigger perfect square, that can save you a bunch of time. In this case, of course, 336 can be thought of as 400 minus 64, and that's 20 squared minus 8 squared, and then applying the special product for a difference of squares, that's 20 minus 8 times 20 plus 8, or 12 times 28.
So that's another great way to factor down 336, and not surprisingly, we end up with the same prime box. So whichever way you go about getting the prime box, once you have it, it's time to start comparing it to the answer choices. You see, if an estimated time is not a factor of 336, or if the actual time is not a factor of 336, I'll go ahead and eliminate those answer choices right away and only look at the ones that remain. I'll eliminate answer choice A because 32 is not a factor of 336, and we can see that very easily by comparing the prime boxes. 32 is 2 to the power of 5. There's not enough 2's in 336 to accommodate 2 to the power of 5. I'll eliminate answer choice C for the same reason. 20 has a 5 in its prime box, but 336 doesn't have any 5's. So therefore 20 is not a factor of 336. Looking at answer choice D, we have the number 18. 18 has 3 squared within it, and there are not enough 3's in 336 to accommodate that, so D is gone too. With only 2 answer choices remaining, I'm going to try one of them. I'll try answer choice B. If it works out, I'll pick it and move on. If it doesn't work out, I'll pick E and move on. What I'll do is I'll take the prime box of 24 and compare it to the prime box of 336 to figure out what's missing, what's the other factor. So if 24 has 2 cubed and 3 to the power of 1, what's missing is 2 to the power of 1, 7 to the power of 1, so that's 14. Now I'll do the same thing with the actual time for answer choice B. So the prime box of 28, that's 2 squared, 7 to the power of 1. Comparing that to the prime box of 336, what's missing? 2 squared, 3 to the power of 1, or 12. So now that we have the 2 factor pairs for answer choice B, all that's left to do is confirm that an increase of 4 hours corresponds with a decrease of $2 per hour, and that works out perfectly. 28 is 4 more than 24, and 12 is 2 less than 14. So I'm going to go ahead and pick answer choice B and move on to the next one.
If you found this video useful, go to quantreasoning.com for a lot more where that came from. You should also click that like button and let me know in the comments below what you'd like me to make future videos about. And of course, if you haven't yet subscribed, go ahead and do that and click that bell below so you get notified about future videos. See you next time.